before about acids and bases and applying them to real life scenarios. This particular topic is kind of a special topic. It's talking about indicators. And this is not covered in your workbooks very well. So I thought I'd split it apart and go through it separately. So with indicators, what we're looking at is a weak acid. So indicators are all weak acids. And so we're going to be writing equilibrium expressions for that indicator and then using weak acid expressions to predict colors of the indicator when it's placed in an acid or a base. We're also going to look at approximate a pH range based on solution colors and using indicators to rank acids in order of strength. The little picture down at the bottom, you can see a bromothymol blue pH indicator, and you can just see that the color transitions that it goes through from a pH of 5.5 to 8.0. And each pH indicator has a different set of pHs that it'll change colors in. So as I previously mentioned, most indicators are weak acids. So we've got an acid form and the conjugate weak base. And the reason it acts as an indicator is because the acid form and the conjugate weak base are different colors. So for example, down here at the bottom, I have the chemical structures for phenolphthalein, and you can see slight differences in the structure of phenolphthalein. The acid form has got an extra bond between an oxygen and carbon, whereas in the base form, that bond is broken and we have another double bond formed between carbon and oxygen has a negative charge. So that difference gives a different color between phenolphtalene's acid form and base form. And over on the right-hand side, you can see that the acid form of the phenolphthalein is colorless, whereas the base form takes on a little pink color, and that pink color gets more vibrant the higher base that you go in. So here's another example. It says an indicator HIND, and indicators have really complex formulas. So IND is just going to kind of indicate that we have an indicator there. The H represents that it's the acid form. And so our indicator HIND has a red acid form and a base yellow form. So we're asked four questions there. What color will the solution be if reactants are favored? What color will the solution be if products are favored? If we have equal concentrations of acid and base forms, and if we add acid. So the first thing that we're going to do is we're going to write out that equilibrium expression. You can see that the acid form, HIND, when we mix it with water, it acts as an acid, so it's going to donate a hydrogen ion. So that's where we're going to get the H3O plus, the hydronium ion from. And we're also going to be left with the conjugate base form of that HIND. So we have IND minus. Now, if the acid form is red, I'm just going to write red below the HIND, and I'm going to write the yellow below the base form IND minus. So what we're going to be looking at is which side we have more of, red or yellow. So if the reactants are favored, we have more HIND than we do IND minus. That means that that solution will be red. Okay. Now the second question here says, what color will the solution be if the products are favored? In that case, we're going to have more of the IND minus than the HIND, and our solution will be yellow. Now with this one, you might want to get out your finger paints. What color will the solution be if we have equal concentrations of HIND and IND minus? If we take our finger paints and we mix yellow and red, we're going to get orange. Finally, question D has to do with shifting equilibrium. If we add hydrochloric acid, basically what we're adding is H3O plus. The chlorine is going to act as a spectator ion. It's not going to do anything, but we're going to be adding hydronium. If we add hydronium to that solution, we're going to shift equilibrium to the left, making more of the red acid form. So you can see there that if we're shifting equilibrium to the left, that means that we're going to have more of the HIND than the IND minus, and the solution will turn red. So what we can conclude here is that if you add a strong acid to an indicator, it will turn the color of its acid form. It'll turn to the HIND. So the little picture down below shows the color transitions that numerous indicator solutions go through. You can see that we've got some common ones, and these are found on your indicator table that I'll introduce in a minute as well. But we've got methyl violet, and its acid form is yellow, its base form is violet. So if you put methyl violet in with a strong acid, it's going to turn yellow. Thymol blue actually goes through two transitions, and we'll talk about why it goes through two transitions in a minute, but its acid form is red, and then its base form is yellow. And this one just happens to be one that can donate 2 protons, and so when it goes through its second change, its second acid form is yellow, and finally the conjugate base is blue. With methyl orange, if you put methyl orange in with a strong acid, it's going to turn red. Methyl red will turn red. Bromothymol blue will be yellow. Phenolphthalein will be colorless, and alizarin yellow will be yellow as well. So the next question asks, what happens if this time we add 1 molar sodium hydroxide? And sodium hydroxide is a strong base. So again, we're going to go back to that equilibrium expression. We've got the HIND plus H2O yields IND minus and H3O plus. Now thinking back to our neutralization, what happens if we add an acid and a base together? We know that if we have hydronium and hydroxide, they're going to neutralize and form water. So essentially what we're doing when we add sodium hydroxide is we're removing hydronium from this formula. So if we remove hydronium from that formula, our equilibrium is going to shift to the right-hand side. That means that we're going to have more IND minus than HIND, and that's going to turn the solution yellow. So it's going to turn to its base form. So our conclusion here, if you add strong base to an indicator, it will turn the color of its base form, IND minus. So that means when we add strong base to methyl violet, it's going to turn its violet color. Thymol blue, it'll go to yellow and then go to blue if we add strong base. And methyl orange will turn yellow, methyl red will turn yellow. All of those base forms are what those indicators will turn to. And that has to do with those equilibrium shifts. So this is the table that I was referencing earlier. It's one more table that you can learn in your data table booklet. And this acid-base indicator chart tells you all about the different types of indicators and the pH range in which the color change occurs. So you can see methyl violet changes color in acidic conditions. So from a pH of 0 to a pH of 1.6, that indicator goes from yellow to blue. Some of the other indicators change colors at more of a neutral kind of range. So bromothymol blue, for example, changes from yellow to blue from a pH range of 6 to 7.6. So it could help you tell if something was neutral or not. Indigo carmine is very basic in which it changes color. So it is blue all the way up to a pH of 11.4 and then turns yellow at anything over a pH of 13.0. So it can be used to distinguish whether something is a very strong weak base or a weak strong base, etc. It can be used to tell your bases apart. So here's a couple of examples of this. It says when a drop of 0.1 molar hydrochloric acid is added to bromocressyl green, the color is yellow. When 0.1 molar sodium hydroxide is added, the color is blue. So it's asking what color is the acid form, HIND. So the first thing that we're going to do is find bromocressyl blue on this chart. You can see that bromocressyl green turns color from 3.8 to 5.4. And you can see that the acid form of this is yellow and the base form of it is blue. So it says, what color is the acid form of HIND? Well, that's going to be yellow. You can see on the chart that the yellow is the acid form. You can also tell from the evidence in this little test, because when we add a strong acid to it, it's going to change to its acid form. It says what color is the base form? Well, when we add the strong base, it's going to turn to blue. So that means its base form is blue. And based on the chart, you can see that the blue is over on the right-hand side, indicating that when that solution gets more basic, it's going to turn to the blue. So there's another way you can figure that out. And then finally, the last question here is our finger painting color. If we have equal concentrations of the acid form and the base form, what is the color? If we mix yellow and blue together, we get green. So the last solution is going to be green. So transition point for an indicator is reached when we have equal concentrations of HIND and IND minus. And we can look at the color of the transition points. We can also talk about the pKa of that transition point. So that mid-range in the pH change is going to be the pKa. And the first question here says, what color is methyl violet at the transition point? We can take a look at methyl violet. You can see that it changes color from yellow to blue. So at the transition point, it's going to be green because you mix yellow and blue together, we get green. Alizarin yellow is the next one. It goes from yellow to red. So at its transition point, we're going to get an orange color. And finally, phenolphthalein goes from colorless to pink. And kind of midway between colorless and pink is a really light pink. And if you've done any titrations in the past, you've probably used phenolphthalein and are going for that really, really faint pink color when you're looking for that transition color. So with transition point and Ka of the indicator, here we have our HIND plus H2O and yielding the H3O plus and the IND minus. That's because indicators are weak acids. If we look at the Ka for this particular reaction, we're going to take our products over our reactants. And you'll notice that when we have the transition point, at the transition point, the concentration of the acid form and the base form is equal. That's why we get that color change in that midway color. So we can cancel those out. So at the transition point, the Ka value is equal to the concentration of the hydronium. And the pKa is equal to the pH of the transition point. So what we're looking for is that pH at the exact middle point of the transition. So pKa equals pH at the transition point. At the transition point, HIND equals the IND negative. And you can see here with the transition of methyl red, we've got the red form when it's in an acid. We've got this yellow form when it's in a base. And midway here, we've got that orange form of the methyl red. That is the color that we're looking at that transition point. And at that transition point, we can tell the pH of that solution because it's going to be midway between the color change range. For example, here's a question. We want to find the Ka for phenyl red. So the first step in this is to find the pKa, or the pH at the transition point. So if I take a look at phenyl red, I can see that it changes color from 6.6 to 8.0. It goes from yellow to red. What I'm going to do is I'm going to find the exact middle value. So I'm going to add those two together, divide by 2. I'm going to find the average value of those two, and the middle value there is 7.3. So my pKa is 7.3. In the next step, it asks us to find what the Ka is. So if this is the pKa, it's just like going from a pH to a hydronium concentration. My pKa, to get rid of the p, I'm going to take 10 raised to the negative 7.3 power. I'm going to take the anti-log of that. So if I take 10 to the negative 7.3, I get 5 times 10 to the negative 8. So there's my solution. Now the last question, or next section here, looks at diprotic indicators. And I mentioned earlier when we were looking at the chart that we've got thymol blue actually undergoes kind of 2 different color changes. And the reason for that is because it goes through 2 ionizations. The first one, we actually have 2 protons that we're going to donate. So in the first one here, you can see that this red highlighted area undergoes a change when we go through that first transition, and it loses a proton. We also go through a second change though, because we have another hydrogen ion that we can release and change colors. So we actually go from a red form to a yellow form, and then a yellow form to a blue form. And we kind of have two Ka values for those different changes as well, depending on the pH range that it changes color. So for Thymol Blue is one of the most useful indicator solutions that we can have when we look at trying to make an indicator that'll change pH across a whole pH range. If you take a look at a pH of 1, here's where our Thymol Blue is. When we have a pH of 1.0, the only form that I'm going to have is the Thymol Blue with 2 extra protons, 2 extra hydrogen ions. And so that form is going to be completely red. At a pH of 2, 2 is midway between that 1.2 and the 2.8. So we're going to have both acid and base forms. So I'm going to be between red and yellow, and that's where I'm going to get my orange form. At a pH of 3, I've transitioned completely to the first weak base form. So I don't have any more of that red left over. I have completely yellow left over. None of it is switched to blue yet. So that one's going to be yellow. And then when we go to a pH of 7, again, it hasn't started to go through that second donation of protons yet. So we're still going to be completely yellow. At a pH of 8.8, we're halfway between the yellow and the blue. So halfway between the yellow and the blue is where I'm going to get that green color. And then finally, when I get to a pH of 10, we've gone through that second ionization altogether. The only form I have is that Thymol Blue 2- left over, and so we're going to be completely blue. So that kind of goes through the different transitions of the Thymol Blue color. So the last kind of section we have here is predicting the color of an indicator based on the pH of the solutions. We're going to go through that, and then we're going to look at ranking acids and bases. So I want to give you guys a minute, pause the video for right now, and see if you can go through and figure out what the pH of the solutions are. So take the negative log of these solutions, because they're all strong acids or strong bases. And then see if you can predict what color the Thymol Blue will turn, what color the methyl red will turn, and what color the alizarin yellow will turn. So pause the video for a sec, and then come back and find the answers. Okay, so here's the answers for this particular question. If you are trying to work it out and it still doesn't make sense, please make sure you contact me and I can go through it as well. But there are the solutions to that problem. Okay, last type of question here is using indicators to rank weak acids. So here's our example. This is a little bit of problem solving. If we add a few drops of indicator to a weak acid, it turns blue. When a few drops of an indicator are added to a different weak acid, it turns red. What we want to do is rank the acids, HA1, HA2, and HIND, in order of increasing strength. So the first thing that we're going to look at is this ionization. We've got the HIND plus H2O, and it goes to IND minus and H3O plus. So if we are adding a few drops of indicator to a weak acid and it's turning blue, it is going away from that HIND form, which means that the indicator is actually stronger than the weak acid because it's going to shift away from the stronger acid. So it's shifting away from the stronger acid. That means that my indicator must be stronger than HA1, that first weak acid. With the second scenario here, if we're adding it to a different weak acid, it turns red and it's turning towards that acid form of the indicator. That means that the indicator must be weaker than the second weak acid, HA2. So in terms of ranking, we can say that our weakest acid had to be HA1, the HIND, the indicator, had to be in the middle, and the strongest acid, HA2, is going to be the strongest because it caused my indicator to shift towards its acid form. So that's it for this lesson. Please try, there's a worksheet on the Google Classroom as well. Try that to go through the questions, make sure that you have an understanding of this section, and please let me know if you have any questions along the way. Thanks for watching. Bye.